For this blog entry, we're going to look at the synthetic imagery from the 4-kilometer NSSL WRF-ARW model, initialized at 0Z, 22 April 2015. And right here we're looking at the 10-hour forecast, so it's valid at 10Z on 22 April. This is the 10.35 micron imagery, so we're looking at the simulated IR imagery band. And what we see here is an MCS that was forecast to move across Oklahoma like so. And commonly one of the forecast questions you have is, where would that MCS outflow boundary be? And in this particular case, it's a forecast, so it's the forecast outflow boundary that you'd be looking at in this hourly imagery here. And you'd be interested to know that because you're going to compare it with the observed data later on to look for some differences. So the low clouds show up in these lighter shade of colors here, these lighter grades of gray and white colors that you see here. So what I'm going to do is just circle this area to keep an eye on right here, and I'm going to go back and forth a few times here. And hopefully as I go back and forth a few times, you get the impression that those low-level clouds are moving towards the southwest. And it is pretty subtle, but as you go back and forth here, you get the impression that we likely have an outflow boundary, something like so here, across the Texas Panhandle, and then moving or oriented back towards this part of North Texas here as well. Let's go ahead and see what happens a little bit later in the day as we move through the forecast time. So here's 18Z, and like I said, it's pretty tough to pick out that outflow boundary. Maybe it's something like so here, the boundary between these low-level clouds and then less low-level clouds to the south. Although notice you do have some low clouds further to the south here that appear to be burning off with daytime heating. And then as we get into the afternoon hours here, notice that we have forecast convection out here in the West Texas Panhandle near the New Mexico border right here. And if we continue to advance along, that storm is forecast by the model to kind of move off in this direction towards the southeast as we get into the early evening hours. So I'll just go ahead and loop that once again. And in summary here, we see this MCS moving across Oklahoma, leaves an outflow boundary which is fairly difficult to detect. And then later we see a storm in the far western Texas Panhandle. Doesn't look like it makes it as far east as the outflow boundary, what we'll see here. Next, what we're going to look at is the synthetic low cloud and fog product to see if that can help us discern that low-level outflow boundary a little bit better. So here's the synthetic low cloud and fog product. It's just the 10.35 minus the 3.9 micron band. Again, forecast imagery that's starting at 10Z. Here's that MCS, which is colored in these gray to black colors moving across Oklahoma. And what we're going to look for is these blue colors here, because the difference shows up in these blue shades here, which is positive difference. And you can see indications of it right here. Maybe shows up a little bit easier in this low cloud and fog product because it's really delineating between low cloud and these higher clouds that are forecast from the model. Notice that there's forecast to be quite a bit of low clouds further to the south in Texas. And then as we move through the daytime hours, you can see higher clouds associated with upper level cirrus further to the south. These low clouds burning off in central Texas. And like I said, you do have some indications of that outflow boundary in that general vicinity right here. Let's go ahead to our forecast afternoon hours here. I'll stop it at 22Z, and you can see our thunderstorm right here. That's not enhanced like it is in the IR, so it's not quite as easy to pick up, but this is really focusing on those low-level boundaries here, the blue colors here. And it is somewhat ambiguous by this particular time, so maybe a little bit earlier it was standing out a little more clearly, something like so here. So Next, what we're going to do is compare this with the GOES imagery to see what actually happened. Here's the GOES visible imagery along with the observations. Here's that MCS up in Oklahoma, and as we advance along a little bit past 16Z, you can pretty clearly see the outflow boundary. I'll go ahead and draw it in, something like this here. So just north of that boundary, you can see some of these stable wave clouds indicating the more stable air mass in place. And then southwest of that, we would have potentially unstable air mass as long as it warms up sufficiently further to the southwest. We advance along a little bit later. I'll stop it right here. And we can see a dry line in place out in western Texas. So you can see the western edge of this field of cumulus being something like so here, where we would have our moist air mass in place just to the east of that. Our boundary of interest that we were looking at looks something like this, where we have our stable wave clouds just north of that boundary in the stable air mass, and then unstable cloud streets parallel to the low-level flow, and these southeasterlies indicating our warm sector that we have coming through this region. Then notice out here we see convective initiation taking place along the dry line near the New Mexico-Texas border. We advance along a little bit later, and we see storms have gone up in this vicinity right here. Looks like our dry line is something like so here in West Texas, going back up towards that storm. And then here's our cumulus streets indicating the unstable air mass right here. And then we have our MCS outflow boundary still in place, approximately something like this. And there's been some modification of it with some daytime heating, but generally it's more stable and drier air mass north of that. And then we have our potentially unstable air mass, our warm, low-level moist air mass over here. So let's go ahead and advance that a little bit further, and we can see that storm move off to the southeast right here towards our warm sector air mass here, our low-level cloud streets, and then continue to move towards the southeast as we get into the evening hours. So in summary, we looked at the synthetic imagery from the NSSL 4-kilometer WRF-ARW model, gave us indications of this MCS, its outflow boundary. It's important to note where it is, just to compare it with the GOES imagery to see where differences may exist, because it may play a role. And in this particular case, there was a storm that initiated along the dry line in far west Texas, and the model seemed to do a pretty good job here in terms of the location of that and the timing of it. And you see this storm move off to the southeast, pretty close to what the model depicted here. So this would be a day where the model had pretty good guidance here, and by following this, not just the storms themselves, but more importantly in the synthetic imagery, looking at those various air masses in place and comparing it to what's actually occurring in the surface obs and the visible imagery.